Let's discuss one sum related to trapezium and we need to prove some inequality. Let's start with the question. In the given figure, prove that CD plus AD plus AB plus BC is greater than twice AC, right? This is what we need to prove. If you recall the sums that we did previously, you can see we have done some like that related to PS1, right? So we are going to take help of that concept and we are going to solve this question. So basically we just need to write that AB plus BC plus next is CD plus DA is greater than twice AC. This is what we need to prove. Again, here we will write AC plus AC. This is what we are going to write it, right? So here as well we are going to divide into two triangles like we did previously. So clearly we can say this is the one triangle and this is the another triangle, right? So let's start with the conditions. So for the triangle ADC, triangle inequality theorem, we are going to use that sum of two sides of triangle is greater than third side, right? We know this very well. And remember, take AC on the RHS side, right? Because we want to prove that. So AC here. So what are the other two sides are left? That will be in sum. That is AD or DA and another is CD. So let's write CD plus DA, right? This is the first result. Now let's focus on the second one. So for second result, which triangle are we going to take? ABC. So let's take triangle ABC and same theorem we will use here. We are going to keep AC on RHS side again because we want AC plus AC. And what are the other two sides? That is AB plus BC. So here greater than sign and here AB plus BC. Now you know what we are going to do, right? We are going to add them. Then only we are going to get twice AC. So let's add. After adding, we will get, first of all, let's write this two part. So AB plus BC, then this two CD plus DA, and on the RHS side AC plus AC. So AC plus AC, right? Now we cannot simplify anything on the LHS side, but RHS side we can do twice AC. So basically we got the result that we wanted to prove. So let's write here AB plus BC plus CD plus DA greater than twice AC, right? So we are done with the result that we need to prove. This is also a very simple question. Like this sum we have already discussed, but here we have the shape of trapezium or quadrilateral, right? So we need to think more like how to do that, but it's simple, right? Focus on the RHS side 2AC, so we are converted into AC plus AC. Then we can see there are two triangles. In this one, we can divide figure into two triangles and we apply the inequality of the triangle, that is sum of two sides is greater than the third one. So apply the inequality theorem for both of the triangles. For triangle, first of all ADC and then triangle ABC. So we can get the results and add those two results as we want 2 times AC. So this is how we prove result given to the figure. Let's prove one more result related to quadrilateral. We have this figure ABCD. Let's read the question. In the given figure, AB and CD are respectively the smallest and the longest side of quadrilateral ABCD. Show that angle A is greater than angle C. So we have AB as the shortest side and CD as the longest. Let's write it. Shortest is what? AB, and longest is what? CD, right? This is the given condition. Let's write here that it is given. Now what we need to prove? We need to prove that angle A is greater than angle angle C. This is what we need to prove. So shortest and longest. This is the chapter related to triangles. So first of all, we are going to divide this quadrilateral into the two triangles. So let's start. Let's divide into the two triangles. Done? Now this is the shortest AB and this is the longest CD. Now we need to prove angle A greater than angle C. So for that, what I'm going to do, I'm going to give name to this angle. These angles are going to vary. Is very helpful. So 1 and 2, 3 and 4, right? So first of all, we are going to write the condition for the first triangle, then condition for the next triangle, and then we are going to add them up, right? For angle A, we can write that angle A is equal to sum of which two angles? See, angle 4 and angle 2. So we can write angle 2 plus angle 4. And for angle C, what we can write, that is angle 3 or angle 1 plus angle 3, right? This result is very helpful at the end of it. So let's start with that. First, let's talk about this triangle ABC. So let's start with triangle ABC, right? Now which is the shortest side? That is AB. So I can write AB is less than BC, right? Remember, you cannot take AC over here because we do not have information related to diagonal of the quadrilateral. We don't have the information. When we compare, we need to compare only these four sides: AB, BC, CD and AD. So out of BC and AD, we know that AD is the smallest side, right? So what about the angles can we conclude? Now opposite to AB is what? Angle 3, right? AB is angle 3. So angle 3 here less than what we can write? Opposite to BC, that is angle 4. Angle 4 it is. Then now let's do the same for the triangle ADC. So triangle ADC. Now here DC or CD will be the longest side. So we will be writing over this side CD, and which will be the comparatively shorter, that is AD. So we can write AD less than CD. Now what about the angles? Opposite to CD is what? Angle 2. So here angle 2, and opposite to angle AD is what? Angle 1. So we can write here angle 1. Now we have two results. This is the first result. This is the second result, right? So we have two results: angle 3 less than angle 4 and angle 1 less than angle 2. Done? Now let's add them up. We know very well that this is the only thing we do. So here on left hand side we have angle 3 plus on here left hand side angle 1 less than, here we have angle 4. So angle 4 plus here angle 2. Now let's compare with this one. So what do we have? Angle 3 and angle 1 means what? Angle C. So angle C is less than here angle 2 and 4, that is angle A, right? So this is what we proved over here. If you are still confused that are these two results are same, that LHS is angle A and here LHS is angle C, then don't get confused. You need to see on which side this mouth is open, right? That is bigger. A is, right? A side mouth is open and A is bigger. Same over here. So you can switch it and you can write further angle A is more than angle C. Wherever side the angle A is there, keep this mouth open. That is what our answer is, right? So we proved that angle A is greater than angle C. This is also a very simple question, right? We use this condition. So far we were having angles with us, right? This time we have the sides, shortest and longest out of this quadrilateral ABCD, right? So we divide it into two parts, right? Quadrilateral as well as the angles which is angle A and angle C. So angle A is divided into 2 and 4, angle C is divided into 1 and 3. So first we talk about the triangle ABC. There are two sides. Remember, do not talk about the diagonals because we don't have information related to diagonals. We are only having information about the sides. So in this triangle ABC, one side is AB, which is the shortest, and another is BC. So AB less than BC. Now opposite to angle AB is what? Opposite to side AB is what? 3, and opposite to side BC is 4. So this is what we have written. And same we have written for triangle ABC. Now we have two results, result 2 and result 1 over here. Add them up and see which is the greater one. So this is how we prove the result related to quadrilateral.